Hello everyone, welcome to VOC 203, TechEd Backstage for 2011. My name's David Connors, I'm the lead network engineer at the event. I've got with me Ben Parker, who is the lead infrastructure consultant. I guess if you split our two roles in half, I sort of look at the lower level networking side of things and also take overall responsibility for the technical deliverables, and Ben is sort of responsible for all of the private cloud stuff that runs on the showcase floor and also powers all of the demos that you would have seen at the event. For the agenda today, we're going to go through and give you a little overview of who the vendors are that are involved, or who the vendors are that we think matter anyway, that are involved in the delivery of the technical parts of the event, give you some facts and figures from what we've delivered this year, and then we'll get into what's actually advertised in the agenda, which is the TCP/IP performance tuning, sort of vendor management talk, and then Ben's going to run us through how the showcase was built and what powers DemoNet. So there are about 80 vendors involved in delivering TechEd. The ones that sort of really are involved in a technical sense are Jack Morton Worldwide. That's Microsoft's agency of record for event marketing worldwide. And they take overall responsibility, overall budgetary responsibility, and organise everything from catering and venue hire and all of that sort of stuff. Joma Blue, who are the guys that you see floating around up the back there in black shirts, they're responsible for all of the logistics and project management. So in terms of getting hundreds of PCs in and out and all of the overall project management, that's their gig. And then we do all of the, I guess, the nerdy technical bits and pieces that complement what they do. In terms of wins this year, in the keynote, we managed to get just on 900 concurrent users in the Wi-Fi and on Wi-Fi, and while we had that level of utilisation, we were getting 1 to 2 millisecond ping times back to the Telstra Internet Direct core in Brisbane, which is pretty exceptional. The peak that we've had for the event so far is 1,781 concurrent users. IP transit this year is obviously even better than we had last year. I think we had a 300 meg redundant link last year. We've got a 500 meg redundant link this year. We've delivered 200 sessions on demand provisioned for sessions, 200 virtual machines provisioned for sessions on demand. We've run up 12 private networks across the venue to support individual speakers where they come in with particularly unique requirements to support their particular talk. And so far we've had 0 network faults, and we'd like to keep it that way to 5 p.m. this afternoon. IP transit providers this year, obviously Telstra, you would have seen their logo all over the building. They gave us a 1,000 meg link, and it's a very, very high performing service. It's a service that goes to a part of their business called Telstra Internet Direct. So you might, it's completely separate from Big Pond, and Big Pond actually buy their services off Telstra Internet Direct internally. And that's what we call an E-line service, or a dedicated fibre link from the venue back to the Charlotte Street Exchange in Brisbane, so we're not subject to any contention issues that there might be at the Southport Exchange. We've also got another supplier called Over the Wire. They gave us a 500 meg link back to Pipe Networks DC2 in Creek Street in Brisbane, and they're there in case, obviously, if something goes wrong with the Telstra link, which it might do from time to time. They provide us also with our IPv6 backhaul. This gives you an idea of what the profile of utilisation on the wireless network looks like for the previous event as well as this one. So for those who aren't aware, the Australian Partner Conference ran last week. And so you can see the sales and marketing guys there for the 3 days. I'm not sure what the peak was. I think it's about 390 by the looks of it. And then you can see the Thursday Association's peak there of 1,781 users. In terms of problems that we had with Wi-Fi this year, we had a situation about 2 days out from the start of the partner conference where we were getting about 20 to 40 random disassociations across the venue every minute, and then it would settle down for a day and then it would flare up again. And that happened immediately after we took all of the venue's wireless gear and patched it over to the core network, which we build in parallel with the one that runs in the venue. So obviously all the fingers are pointing at us as being the cause of the problem, but it turned out it was a firmware upgrade that was required on the wireless LAN controller. As you can see, the best comedy material in the talk is actually written by Cisco themselves. So once we actually worked out, or once they worked out that they do sell a product called a WLC 5508, we were able to have a talk about getting the problem towards a resolution. Other random IP bits that are of interest, IPv4, there's none left, as you all would have seen in the press. And not only that, but AppNic wouldn't even give us a temporary allocation. So normally we just get one. We say, look, we just need it for 2 months, and we'll give it straight back. And you can see there from the ironically named Mr. Tom Do, who said, no, you can't have any IP addresses. So his name should probably be Tom Don't or Can't. This year we've got BGP routing on site, so we're actually operating almost as like an ISP. So if you go and look up the AS number that our traffic originates from, you'll see that it shows up as Microsoft TechEd in the AppNic database, and so that lets us do more seamless failover if we have an issue with the link, and also actually make use of the 1,500 megabits of aggregate bandwidth as opposed to having a gigabit that we fail over to 500, which is sitting there unused. And then, of course, again this year you would have seen IPv6 native connectivity throughout the venue, and that's a standard operating procedure and will be so for the foreseeable future with TechEd. This is what the design of the MDF looked like this year. So when we build the event, operationally, the venue actually has a lot of technical dependencies on their network for things like their VoIP phones, VoIP mobile handsets that all of the operations staff use. So we can't just come in and start making wholesale changes, or we'll actually have quite a big impact on the way their business runs. So what we do is we actually build an entire network across the whole building in parallel to their network, and they've got plenty of fibre ties to all the IDFs around the building, so you can make use of that. So you can see that the core router is a Brocade CER that's about a $30,000 router that's capable of taking full IP tables, so we can do proper BGP routing. We take the service from over the wire and from Telstra and route it via, or use that router. We use 35, 50, 12Gs in a stack, those Ciscos, to do the fibre distribution out to the various parts of the venue, and you can obviously see the Cisco WLC. If you haven't seen TechEdBackstage.net, it's worth checking out. That's the site where we put a lot of information about the sort of troubleshooting stuff that we go on in the build out of the event infrastructure, and there's a very long and sordid tale of woe between me and that bloody WLC, starting back in 2009 to get the wireless to the point where it is today, where you can have 2,000 concurrent users. The IDF design, so there's 13 IDFs throughout the building, and it's unique in that there's not that many ports or individual users in a building of this size, but because it's actually quite big, there's a heavy use of fibre throughout for distribution to switches, which you normally wouldn't see in a commercial environment. And one of the challenges we have is the building was built in two halves, so the original building was built in 2002, then extended sometime after that. And you can see with some of the, I apologise for the text, it's too small to read there, but what those arrows indicate is just the difference in patching and utilisation of fibre throughout the building. The green arrows are actually pointing to individual IDFs that just have a slightly different wavelength of fibre that's being used to back all the stuff to the MDF. So we had to go through for a period of a day, months before the event, and do a complete audit of what every single fibre tie in the building had in it. And you'd sort of think that those two, it makes sense that those two on the far right there have the most modern standard for in-building fibre distribution on it, because it's the most recently built part of the building. But then, of course, there's one down the bottom where the jarhead who cabled the building originally thought, I'll just use just for the arena, which we're standing in, I'll just use a different type of fibre for just that one patch to keep me on my toes. And then, of course, throughout the building, it's just a random mismatch of multi-mode fibre between two different wavelengths, and then also just chuck a bit of single mode in there just to really keep you on your toes. With no documentation, but it is documented now. So that's what we delivered this year. The talk as advertised in the schedule builder is in two parts: IP transit, getting what you pay for, and then Ben's going to cover off the cloud part after we go through this. The interesting problem that we have at these events is obviously we've got an absolute bucket load of concurrent users and very high expectations. So if anything goes wrong, you guys are pretty savage on Twitter, and we don't get a lot of slack. And so I end up having to do quite rigorous performance tuning and performance testing well before any of you come on site. And I end up always, as David Haysom from Joma Blue will know well, end up in very heated discussions that sometimes go for weeks with whoever the IP transit providers are to sort of whip them into shape. This year, funnily enough, that I actually am talking about this, Telstra did a fantastic job and delivered the link exactly as we needed it 30 days out, which is completely unheard of. Last year, we actually went live with the Internet link 45 minutes before the keynote. So the sorts of things we look for in our transit providers, obviously we want great performance for typical usage scenarios. So what you'll see as we talk through this is that the sorts of people that you're arguing with generally on the help desk tend to use that very non-helpful, aggressive sort of engagement that you get where they start talking about specific technical issues that actually don't matter to end-user performance. So for us, what really matters is when you're browsing the web, what's the performance like? And we want to think that we can significantly exceed whatever your typical performance expectations are from either working in a good, well-equipped office or having a good internet link at home. And I think, unless you work at NBN Co, this is probably about as good as it gets, what's delivered in this building. Also, obviously, there's the issue of wanting you guys to, tweet about the event as being a great success and being able to work, because some of you have got operational support capabilities that you need to sort of meet back in your office. For Microsoft, we're obviously obligated to protect their brand, and we all sign very detailed contracts that say what we're obligated to do in that regard. And then for us, obviously, it's a matter of pride that we can be seen as doing our job properly. I'm going to give you a few primers, and it's difficult to talk about this content at a particular level. Like it's difficult to peg the talk exactly at level 200 or 300 or 400. So I apologise, I sort of have to go up and down the complexity stack to sort of get some of the points across, but hopefully it'll all make sense in the end as to how some of these excuses that they use against you, what really is ticking behind the scenes so that you can know what is actually rubbish and what is correct. The first thing is just a primer on Ethernet. Back in the day, and this is like before I was at uni, networks tended to be what they call clocked, synchronously clocked. And what that meant is that if you had a whole bunch of nodes on a network, every device that was transmitting and receiving would actually have a clock internally and know, now's the time to send a packet of data, now's my slot to send something. And it was an enormously expensive endeavour because, as you can imagine, to get the performance or that clocking accuracy down to the level that you need to make a network work at high speed, accurate clocks to that level are horrendously expensive and difficult to keep in tune. And so when Ethernet was invented, it came up with this brilliant and simple, clever design of self-clocking. So every frame that hits the wire actually contains the clocking information for the other stations on the network to use. So immensely cheap, very flexible. What the trade-off is that Ethernet is sort of just throw stuff against the wall or throw stuff down the wire and see if it works. So it's subject to having collisions because all the stations aren't working in unison, but the cost, benefit and flexibility that you get from its design far outweigh that. So the implication in a business sense is that as Ethernet tends to get congested, it's completely useless. And so you might as well just unplug it or turn it off. That's part of the reason why we have to massively over-provision the bandwidth at the events, because whilst we might sustain, say, 300 or 400 megabits a second of IP transit, we really need to make sure that we can also sustain 10 seconds of 100% link utilization, or 10 seconds of 800 megabits, sorry. So that's sort of, you've got to keep that in the back of your mind when you think about all of the discussions about whether my link's congested or what sort of performance I should be getting down the link. You've got to remember that Ethernet's fundamentally lossy, fundamentally based on the concept that there will be collisions. In terms of the Internet Protocol Suite, people normally think of, depending on whether you're a network engineer or not, people normally just think of TCP and UDP as being the only protocols on the Internet. There's many protocols in the Internet Protocol Suite, and they all work in unison to meet different use cases for end users. And so what we're going to do really is talk about TCP today, because TCP is the one that matters. TCP is the protocol that you use to access the web, watch YouTube videos and all that sort of stuff. So part of TCP, it has built into the protocol congestion management, and the interesting thing is that it just works. And you'll see times where you might go to download a file on FastLink here, and you'll see the performance is quite slow, and then it sort of ramps up over a period of time to where you reach a stable plateau of performance, and then it will continue to download at that rate. And that ramping up to that download speed is actually the congestion management and traffic flow control stuff that's baked into TCP/IP in action. It's not very deterministic because, like everything on the internet, it's built to be resilient. So we've moved away from that very tightly managed, clocked network world into something that's very asynchronous and lossy, and TCP/IP does that very well. If you look at a typical internet use case like this one here, the interesting thing is that if you've got, say, a user on the internet downloading something from overseas, there might be 5 or 10 or 15 hops of network transit between you and that place overseas. And in this particular example, which I drafted up, you can see that we propose that the server's got 1 gig of connectivity coming out of it, that their IP transit provider's got 10 gig. There's a dodgy ISP in the middle somewhere who's cheaped out and has only got an 80 megabit transit link before it hits 10 gig at this fellow's local ISP, and then it comes down via his DSL modem at 10 megabits a second. On the return path, we've got the traffic obviously having a different shape. So there's some observations you make from this. Firstly is that what I've deliberately shown there is that the path in red and the path in green have different performance characteristics, and that's because the way routing works on the internet is every packet, there's a key concept to keep in your head, every packet is on its own little adventure to a particular destination on the internet. So just the same way Ethernet is sort of fire and forget, self-clocking, just chuck it out there and hopefully it'll get to wherever it's got to go, the internet's very much based on that as well. So you can end up with traffic paths where you might be downloading something, your request to download something goes via a particular path, and then maybe, potentially even via a slow international link, the return data might come back. And you'll find ISPs always want to cheap out, always, right? So they'll find, oh, geez, we're getting a heavy spike of traffic from this particular transit port. Oh, well, let's send that via the dodgy, category B, low quality link that we've got with some other provider. And so you really have to watch where your traffic's going to understand, how their cost-saving decisions are affecting the ultimate experience that end users get at the event. The reality is that in between us here at the venue and 4chan, there's actually 15 hops. And the interesting thing to think about in terms of latency is what I showed here is that it's 161 milliseconds. If you wonder where that figure comes from, with old Wolfram Alpha.
You're not on this page, right?
Okay.
Flip it up.
Sorry. Pardon me. This is going to be a very big challenge for me. So if you have a look at Wolfram Alpha, you type in time from how is that, considering I can't see what I'm typing? Close enough. It'll probably work it out if it's as good as I say it is. So what was supposed to be a very quick demo, which failed spectacularly, is me showing you the actual time it takes for IP transit, or what the governing factors are on the speed of IP transit from overseas. So once this thing's finished working it out for you, you'll see that what Wolfram thinks is you've got the speed of light from, oh, I give up. Anyway, sorry about that. I wasn't counting on not being able to read the actual presentation. So what you work out when you do that sum properly is that 69 milliseconds is the time that it takes to go, roughly speaking, from here in glass fibre to Los Angeles. And then, of course, the data has to come back as a response. So when you look at that 161 milliseconds, you can immediately account for 120 or more of that straight just on the speed of light time. So the implication for us in Australia is a lot of the assets and things that we like to use overseas are obviously, or a lot of the assets we like to use on the internet are based overseas, and so we are subject to that very high latency transit time over there and back for most web properties. And so if you think about what this user might be doing on the internet, he's going to get a pretty terrible experience if every time he requests a packet of data from overseas, we have to send a request for that, wait for the small piece of data to come back and be acknowledged before we dispatch another request out to the server to retrieve it. And so obviously that's not going to scale very well as the latency increases, and the latency is almost always very high for us in Australia. And so that's actually not how TCP/IP works. TCP/IP works more like this, which is as you start to request data, multiple requests for data are sent in flight and kept in flight over a period of time, and then the acknowledgements come back gradually. And there's a lot of fairly complex stuff and lots of different congestion avoidance algorithms, which you can Google about after this talk. But what happens is basically TCP self-tunes. It sort of fires off a few requests, keeps tabs on, oh, there's 5 packets there, I haven't heard anything back. So I'll make the assumption that because it's 5 packets in flight, for argument's sake, that I've not heard anything back, that a link on the path is congested. So it might, that's what that slow start ramping up phase that you see is about. So you'll actually see TCP self-tuning to every possible link in the path between you and wherever it is that you're going to, even though there's no possible way for you to know what those paths are between you and the destination, and the traffic might actually transit via 2 different paths. So it's, when you look at it like objectively and sort of think about how networks used to work when they were clocked, it's a very, very beautiful and very, very simple design, and it works fantastically. And it will automatically tune to not smash the weakest link in that transit path. So that's all true, but it's not a get out of jail free card. And the important thing is that every supplier will use what's called the bandwidth delay product as an excuse. So they'll say, for argument's sake, oh, well, you can't expect a certain amount of performance in a single TCP stream because of that limitation of the amount of data that you can keep in flight between the source and the destination. That's true, and like every good story that gets people out of trouble, that grain of truth is then used as the excuse. In reality, when you're talking about very high performance commercial grade fibre links and destinations that are quite close to home, it's quite fair for you to expect, if you're negotiating with an IP transit provider, that the performance should be pretty exceptional. And so almost, in every case that we see where the performance is poor, it's not because of the bandwidth delay product. Well, it is, but it's caused by faults in their network that cause that to be higher than it should be. So how do you know what performance you should expect out of your corporate network back in the office? Get a bandwidth delay product calculator on the internet. There's a million of them. Punch in the figures, and you'll get some idea about what the maximum performance is you should expect to see from your link. In terms of tools that they use, iPerf is almost universally used. I hate it with a passion. And every time I have a performance issue, the response that will come back is I can get 500 megabits a second of UDP traffic down this link with iPerf and 1,000 threads running at once, therefore it's fine, which would be okay, except for the fact that nobody actually has 1,000 threads of UDP traffic going down a link ever in the real world. Would be great if we wanted to have really fast DNS, but again, not real world, and it comes back to what we want is great performance for what people actually do. And funnily enough, most deep packet inspection systems, which is where the performance problems normally are fundamentally based on TCP, because that's normally the traffic that you want to inspect to see which sort of websites people are going to. So I guess the fundamental underlying point about how you interact with those suppliers when you're having these discussions is don't let yourself get bamboozled by the excuses that they use. Go back and do your first principles research, and you'll work out that they're almost always lying. The part of what we have to do is just stick with those key quality service providers that we use at the events. And going to Telstra Internet Direct, you're dealing with a really high quality commercial grade service where they're selling to Defence Department and all those sorts of clients who just don't take excuses at all. So we actually specify when we deal with our service providers that we want that type of relationship. We don't want a cheaped out commercial grade version that's got high contention, and so that's normally the way we solve that issue. And then the level 2 help desk at those places is sort of like level 6 at any other ISP. What was your question? Just do a TCP download and make sure from a site on the other end of the link and make sure it matches roughly what you'd expect from a BPD calculator, pretty much. And I'm just dogged. I just nag them constantly and just keep tickets open for weeks until I get that result. The problem is that they always use these sort of this sort of arrogant, heavy-handed explanation of why they think a particular problem, and then eventually you start scratching your head and go, well, maybe I'm wrong. Maybe I shouldn't be expecting this, and they sort of bring you around to their way of thinking until a week later you realise, God, the event starts. So no, I really do need to have it perform at this particular level. Best excuses ever. This one came this year from a guy who was so angry at me he was spitting in my face practically, and I thought he was going to punch me over wanting to run his own little access point in the corner rather than using the $500,000 one bolted to the roof. And he actually said, I've got 20 years of network experience, and I really thought I was going to get punched and I had to run. What do you say when someone says something like that to you? I don't know, mate, A, ping is very relevant for measuring latency, and B, it's not based on UDP, so you're a muppet. The other one, FTP, can't use that for bandwidth testing because it's adaptive. No idea what that means, but that was the reason. What was funny about that is once we dug into the performance problems, we actually worked out that there wasn't as much bandwidth going off the island as they were purporting to sell to us once we cut to the real core of the issue. So, FTP probably wasn't the issue there. From that same place, that literally happened to me a week before the partner conference some years ago. A guy walked in with a Netcom NB9, had cables hanging out the back of it, had been smashed. I said, I'm here to install your 6 meg link. I sort of just looked at him, I didn't really know what to say. And that's another gotcha as well. In commercial sense, you always think when you order a 6 meg link, a 10 meg link, a 20 meg link, it is accepted, it is a full duplex symmetrical link, right? When you order a 20 meg link at home, it's accepted, it's DSL, and it's asymmetrical. I now have to specify that in the statements of works to our IP providers, just in case they try and pull something like this to us. In terms of this one, that was great. Waited up till 2 a.m. in the pissing rain for a technician to come out to fix a problem with our ATM service. You can obviously see the issue there. It was an OC3 fibre link. He came out to fix a automatic teller machine, so he wasn't much use to us. And this is another one which is this is from this year as well. You might have noticed you weren't able to get the schedule builder earlier in the week. It's because Hurricane Irene logged into a DNS server and deleted some zones, apparently. So I'd change your passwords next time a storm blows in. So, you know, I mean, I don't even... You get to the point where you go back to your vendor managers at Microsoft and go, I give up, you know, like... I can't answer something like that. And you get the email thread and think, I don't know what the politically correct way is to respond to that. So hopefully that'll give you a bit of an insight into the sorts of steps we go through. But I guess the underlying point is don't take the excuses from the ISPs. If you're buying a 100 meg fibre link, you're entitled, at least in terms of local TCP transit, to get something that performs pretty close to that. And if you're not at work, start digging, and I think you'll find that, you know, you could get some service level refunds from people. So I'll hand over to Ben now. He's going to go through and talk about the cloud stuff. I'll preempt the inevitable question, which is going to come from the audience. The issues to do with the PCTT labs were performed by a different vendor, not us, and that's all I can really say. Obviously, you have to go to Microsoft PR if you want to get anything more than that, but it's nothing to do with this infrastructure and not related to Ben's service delivery. So I'll hand over to Ben now.
Great, thanks, David. So, and just to build on that, so the cloud.au TechEd.net this year is what's been power behind the DemoNet infrastructure, which is basically the presenter. There's a private cloud supporting demonstrations throughout the entire event. So they've got a number of speakers who have taken us up on the opportunity to put their virtual machines and infrastructure onto our private cloud, and also the showcase. So the various vendors that are down there have got virtual machines hosted all in that infrastructure located on the showcase floor. The stats, you can read them yourself, but 28 private clouds supporting 28 sessions. We've grouped every session into a cloud, and as such, you know, they've all got a number of virtual machines, and some even, particularly the IT Pro Plenary, they had a number of dedicated hosts. And also this year, we've also built out a set of networks as well to support them. So the desk that I'm standing at behind here has obviously an Ethernet switch, which is connected to the laptops, and to make it easier for people who are demonstrating sort of very specific cases where they bring their entire, you know, portable organisation, which has got DHCP, DNS, WDS for imaging and builds. We provision them and isolate them right down so that they have no impact on anyone else presenting. So,
yeah. So one thing that we did new this year is we actually ran up a number of private networks across the venue. Ben asked for it. I said, you know, no one's going to use it, so I gave him eight set-aside VLANs to use. It turned out to be extremely popular, much to my embarrassment. But what we do is we run that right through the core and out to every single room and wall port that we control. So if somebody wants to have their particular instance of Contoso with SharePoint, their own Active Directory and WDS servers in here, out by the coffee stand, and in the speaker room, we can do that just with a simple help desk ticket raised, and we just repatch the ports to the right logical network. And obviously, from our point of view, that's a great risk mitigation feature, because these people come with these, like they literally are an enterprise on a USB hard drive, and if you unleash that on the same layer 2 network as you guys, disaster ensues. So we'll be doing more of that next year, I think. So
yeah, it's worked out great, and I think, you know, next year I'm going to be asking for 100, not 8. So basically, so when a speaker registers for TechEd and expresses interest, they're presented with an option to host on the DemoNet infrastructure, and that starts off as a set of communications well before the event. Once we have got the infrastructure confirmed from HP or whoever the hardware sponsor is, we'll start working with each of the speakers to work out what their requirements are up front, you know, whether it be dedicated hosts or just a single virtual machine with a public IP. Once on site, when the infrastructure's here and been powered up, we sit down individually, one-on-one with the speaker, and recapture those requirements again, if they've changed, and also import their entire Contoso domains. I don't know how many times I saw Contoso this week, but it was a fair few. One Woodgrove Bank, many Contosos, from their USB hard drive into the infrastructure. This comes back to the conditions that we work in. So when you think of, I mean, you've all seen the expo hall and you've all seen the servers there. These things sort of ring true that it's not Polaris. It's not, you know, it's got uninterrupted power supply. Interruptions all the time, actually.
Yeah, UPSs don't protect you from people pulling plugs out, generally, two at once. So.
And the biggest concern, I guess, is people knocking beers over. valid concern, and a lot of power going underneath that floor there. So we
probably won't mix three-screen racing car driving and the server room next year again.
That's right. So it's very much for layout rather than purpose. So it's just not a data center. It's just 3 pieces of perspex. The physical access to it, of course, as well, is something that I left with David. And this is kind of what I set out to him to say, look, this is what we need for locking it down so we've got many people that can access it at any one time. The solution, however, a key on a chili hot bottle with the rest of the core infrastructure at TechEd.
So the question is, did it work?
It did.
Yeah,
worked very well.
There you go. It's a good cost-down solution. Yeah, OH&S. I don't get away with much, actually, with the OH&S department up the back smirking at me. So,
and going back to that logistics and building on that, so TechEd for David and I, as he mentioned, starts many, many weeks before the actual event. And the timeline this year was we had infrastructure from HP shipped to Codify in Brisbane, arrived on the 2nd of August, and both from Sydney and Singapore. We build up the environment, and from there it's new infrastructure, so we go through, do all the firmware revisions, make sure they're all at a stable level, build the core OS and the basics to support the environment, so DNS, DHCP, AD, etc. From there, the other key point is it's built on the same IP network as what is here at the event, so we can power it down and move it, which is that next step.
Well, it's actually, yeah, it's the same layer 2 network. So all of those demo VLANs that we mentioned and the delegate network that you're accessing now, we actually had all of that simultaneously operating both in our office in Brisbane and also patched down to here in the convention centre. So you could actually have like one of the VMs running in Brisbane talking over the same private network to something that's part deployed in the convention centre.
And then on Friday, we bring it all down here and plug it in and make it turn on. So again, it just works. It's just all straight from Brisbane. So what I've got here, and I'm going to have the same problem.
I think your demo's about to
yeah,
fall the same fate as mine. Should be right, yeah. So,
it's gone now.
We'll put that up on TechEd Backstage for you later, but it's funny because of how little actually is achieved in the amount of time that time-lapse caught. I think you managed to roll a rack off one of the pallets, didn't you?
Oh, that's right, yeah. I think it's great to see that because, I mean, you're sitting there and you're like, right, these 3 racks here, but we'll get the designer in to have a look and say, oh, well, the power box is over here, but network, and you have, it's interesting sort of laying that stuff out. It's not, you go to a data center, it's like, that's my rack, put it in. It's, a lot of effort goes into working out what that looks like and how it's all arranged, and then the connectivity back out of that.
And the constraints we work under there, obviously a lot of it is designed for visual purpose, right? So, it might be quite logical to have something here, but it doesn't look right. So it's got to be there. And once that floor goes down, it filters with terror because there's only, I think it was 13 mil, David, was it? Or was Mr. Haysom up there? Yeah, so 13 mil gap under that floor, and that's all just put down and fixed and screwed in. So once the cabling's in and everything's on top of it, the decisions are made, and we can't have an event like TechEd with gaffer patches running over the top of the showcase. It's just not an option. So.
And building on from that, I guess that comes to the next point, is that floating floor. I mean, last year in 2009, we actually had an issue where once we got load on that floor, people walking around on it, it actually severed one of the cables underneath, so we had to go to a backup failover network port, which went to another IDF. So again, when we're talking about designing what we're doing for DemoNet, it's somewhat different to what you would normally do in an enterprise in the fact that we always go for the highest set of resilience in the environment. So for example, we've got Hyper-V clusters going across both racks. So node 1, node 2. The reason we do that is because the power, etc., comes from the central location, but they're different patch ports, etc. Same with the network. They go to different IDFs to each rack, so we want to make sure that we can always get to a VM no matter how many people stand on the one spot and jump on down and sever a cable for us. So we make sure we have one going to each rack. That flows through. You can see that in the storage design. We prefer RAID 6, given the option, so we can always have 2 physical drive failures. And I mean, power comes down to all layout configuration as well. I mean, they can only provide us with one 3-phase 32 amp socket out of the venue floor, so we just have to make do with that. And we've got a distribution box there that splits that out over a number of circuit breakers. The shared services component around the design, I suppose we maintain a lot of core infrastructure. So this year we've used Virtual Machine Manager 2012 and Hyper-V exclusively in the environment, and that requires a set of infrastructure underneath. We've got 2 physical blades dedicated just to managing that, and they're again on separate ones, and it's just standalone virtual machines that are crossed over, ready to go at a moment's notice where we can swap and turn them on and stuff. So the actual hardware, we've got, so HP have kindly donated for the event 24 of their latest enclosures and latest blades. They've given us the Virtual Connect and server engine stuff, and to be honest, it's some really quite exciting stuff. I'm just going to flip over and do a quick demo, maybe.
Yeah, that's right. It takes a while. Done.
Right, so what I've got here, this is the Virtual Connect console. And if you're not familiar with server engines or you haven't seen it before, essentially it's a 10 gig bus on the back of each of these blades, which is essentially what your mezzanine cards were. Now, server engines came up with a concept that you can have both fibre channel over Ethernet and Ethernet in the one module, and you get that 10 gig and you can do whatever you want with it. You can have 1 gig for network, 8 gig for storage, and vice versa.
So the idea there is, you know, hopefully you've just got this one cable at the back, so when you're talking about really high dense scenarios in a data center, it reduces a cable clutter by an order of magnitude is I guess the underlying reason why they do that.
That's right, and it's customizable on the fly as well. You can just select the port speed, and there's a preferred on, you can let it auto balance itself, or you can actually define a number of them. Because we've got only a 1 gig backhaul back to the core infrastructure that's in the MDF, I've gone for a 2 gig network, so that way I get enhanced bandwidth across the enclosure, but I still only have 1 gig out, and boosted the storage so that I've got, that's the tuning, excuse the flash interface, but and then for the storage I've got 8 gig dedicated to back to the SAN. So moving on to the SAN, so this year HP EVA HSV 300, 20 terabyte usable RAID 6 is what it's boiled down to. Of that, 79% is in use of at 9 AM this morning. So we do take a fair chunk of storage and we do use most of it all up. The reason for that, I guess, is we've got in-flight virtual machines and presentations going at the moment, and we also maintain the original copy that was provided by the speaker at the time. So if there's ever an issue with a snapshot or whatever they've taken, we can always just roll back to that original provided set. I've already done the demo, but that's fine. So the hardware layout, so this builds on to the resilience, and I want to show you that in how we've set up the environment. So the SAN on the right here makes, it's fairly self-explanatory. The set of disks, the 45 disks to get us our 20 terabyte. The additional disks are all 1 terabyte fibre ATA, so essentially SATA with a fibre interface. It's all backup storage, so we've backed up our core infrastructure onto that, but it's not actually in production use. It's the physical server rack layout. The purple, that's our clusters, so we've got individual nodes, so blade 1 on enclosure 1 and enclosure 3 maps, and that's part of the cluster. The ones down the bottom, the ones in green, they're our core infrastructure servers, so AD, DNS, DHCP. And the orange boxes are ones that we've given out for, physical demos, so people who have got their own SCCM labs. I think based on the number that I dished out this year, I'm sure you guys have seen enough VMM and enough SCCM to last a lifetime. Management of the whole environment is done this year with VMM 2012 in the beta form. A couple of the things that we went through this year and did, which are the key highlights for the product set, is bare metal builds. So it's a new feature in 2012 where you'll be able to point your VMM server at an ILO, and it will then take control, log in, and configure Pixie boot services and manage the WinPE installation, etc. So to do that for the HPs, there was a pretty specific process. It's well documented. There are a couple of gotchas that we found, but they're more to do with being a beta release. Mark Rhodes actually demonstrated this in his session, so I won't go through the video that he's got, but it has been recorded and is available. The basic steps are first WinPE with the HP Smart Suite, second to Windows Server 2008 R2. So at that stage, we have a base OS with the core drivers for network and SAN. We then have to enable Hyper-V role. Traditionally, whenever I've built a server, I always go and run the HP ProLiant support back, or the PSP, because it has that HP network configuration utility. Now, if you're familiar with HP servers, the NCU, as it's called, has a whole bunch of features that enable network teaming and advanced TCP offload and receive-side scaling, which, when installed next to Hyper-V, the recommendation is install it after you install Hyper-V, because the NCU's actually got some specific configuration that's dependent on the installation of Hyper-V beforehand. So there's a great white paper by HP that's actually going to be up on our Backstage blog next week that goes through and says, look, this is the required order. If you don't do it this way, you're going to have to pretty much rebuild your server. So it was a bit of a gotcha, but we sat down and worked it all out. Once we've got that, we get the PSP down and then the remaining SAN management tools. So for all those blades that I was showing you, they were all done, well, all but two were done via this method, so pushed out via VMM. Some of the other features that we're using in VMM is templates. So we've got virtual machine templates, which we took the install.wim and used Wim to VHD, which is a free tool, and updated it with a Windows PE to basically create an unattended answer file as well. So that way we can push out a number of virtual machines on request for any speakers that want just a vanilla build. Additionally to that, we're using the self-service portal, or the SSP. It's fantastic. It's what we give every speaker access to, and they can manage their infrastructure from that website. Checkpoints, stop, start, export even into the library and then take it home with them. It's a very flexible interface, and the remote desktop has been greatly improved this year, and it's now actually extremely usable. And the remote console is actually what some of the guys have been demoing in their actual sessions. So that really sums up a lot of the private cloud stuff. And
so we're hoping to run the last part of the session as a Q&A. Last year, unfortunately, we ended up with overlapping into the following session after us, based on the fact that we had about 20 minutes worth of a Q&A and about 0 minutes worth of time left at the end. So I guess, what sort of questions do you guys have about the infrastructure that was built, and did I make an error in judgment in making that decision for this year? Maybe. No?
Oh, yep.
Did you get it all from Brisbane to here?
Yes, yeah. So all the HP equipment was delivered to Codify on the back of a big truck, and we packaged it here. And then again on Wednesday the 24th, it was all packed and shipped down to the Gold Coast and powered up once they started building the showcase floor. So we obviously rely on the showcase floor. As in, no issues. No, it all powered on. No faults, nothing at all. So just works seamlessly. Yep. Oh, yep, up the back.
How do you extend the layer 2 from Brisbane down to the Gold Coast?
So the layer 2 service that Pipe delivers is using Q-on-Q. So yeah, so they obviously use the outer 802.1q tunnel for themselves, and then we just tag over the top of that. Yeah, so it relies on obviously a very close working relationship with your IP transit providers to get that sort of flexibility, and it required that we renumber all of the VLANs that we were using at the event to not collide with their infrastructure. So they're very, very good to us.
That was a...
Yep.
You guys run 1252 access points, or
1252 AGNs, dual radio interfaces. They're the ones with the PCI slot on them, and you can put in a 2.4 and a 5 gig radio. Yeah, so they're all up in the ceiling cavity. If you look around, you'll actually see the MIMO antennas in the ceiling from place to place for the 5 gig and the 2.4.
Yep. It's a great example outside meeting room 9, I think.
Yeah, yep.
If you look up
you know, despite all the jip I've given Cisco over the years on TechEd Backstage, you can't deny the results of how it's tuned now. I mean, it's a fantastic experience for delegates, and I think, you know, after it was all the issues were ironed out and the right product was deployed as opposed to the wrong one, which was the issue, the key issue originally. It's great here, and the venue use it like it's core for them. Like all of their ops staff are doing stuff on Wi-Fi phones. We did go and see Melbourne Convention Centre once, and it's even more interesting the dependencies they've got on Wi-Fi there, because they actually use it for all their OHS and F&B tracking. So the trolleys are actually integrated with some Cisco product, so that when food leaves the kitchen, it's actually logged, and then it knows, like the system knows to call someone to go and get the food that's about to go off and take it off the floor. Very, very advanced stuff. So I think, you know, the way things are now, and we've had a few brief discussions just within the technology team, I doubt we'll do wide for delegates, depending on what we've got in the building. I think the technology is now mature enough that I don't think that anyone actually has a legitimate business need for having a 1 gig tail to their laptop. And certainly when you look at the IP transit figures of what we're using, you know, like you're not going to get a single gig TCP stream from download.microsoft.com in the US for all the reasons I just outlined in the first talk anyway. So, yep.
Oh, yep.
Is there any reason that you chose to have an unencrypted wireless network and didn't use any WPA?
Yep. So WPA with the shared key is as good as open, because everyone knows what the key is and they'll give it out. Secondly, if we use like some sort of proper ingress, certificate-based stuff, anyone who wants to put their hand up for issuing 3,500 certificates for 3 days is welcome to the job. So we just treat it like a public hotspot. We're very clear about that in the conference terms and conditions, that basically use SSL, use VPNs if you're doing anything secure, but it's more an operational reality of doing something that's going to run for 3 days with essentially 3,000 anonymous people. Yep. There's a gentleman here, yep. Oh, look, you know, it's not really our job to police what people do. The only time I take interest is if I see a port running pretty hot, and unfortunately Nick's shot across the bow at you all in the keynote saying that you're going to get banned from the network if you're caught. BitTorrenting seems to have worked reasonably well. Obviously people are doing it, but it's not like, you know, not like the 2 years ago where people would just go turn off all the governors and have like 5,000 peers taking up the entire link. So I was actually a little bit worried about that this year because we gave you all public address space. I don't know if you noticed, but the IPv4 address that you had was actually public IPv4 space that belongs to Codify. So you weren't actually behind that. I thought this is either going to be really good or really bad. We'll see what the BitTorrent traffic looks like when people have got no firewall policy between them and the rest of the internet. But seems to have been quite good. So, yep.
Another one here.
Yeah, it's a difficult thing because the way networking is, it's a cost issue predominantly. The way networking's going is, you know, we went from 10 meg to 100 meg very quickly. It took like 15 years to get to gig really, and it's still bloody dear, right? If you wanted to get a 48 port all gig distribution switch, it's prohibitively expensive, and it's like a high-end Cisco, you don't get change out of 30K rack rates, you know, for 3750 or something like that. And then 10 gig, like, you know, it's $2,000 for a NIC still. So the issue that we predominantly have in these buildings is getting the density of fibre or SFP or GBIC ports in a unit that's actually cost effective for such a temporary deployment. And that's why we use the 3550s, because they're great, they're rock solid, great layer 2 switching devices, and we can get that density in them pretty easily. So we just get them, and I don't know if you noticed in that diagram, but they're up on TechEd Backstage. We just run lag trunks between them, so there's a 2 gig backbone that runs up the guts of them, and we use a 2 gig cross connect to the brocade and then just 1 gig out from there. So we've used a fair amount of Juniper stuff in the fleet for the first time this year, yeah, it's interesting. I mean, I'm a bit of a fan of the gear. It's quite cost effective. Junos is very good in my opinion. There's a lot of really smart stuff you can do around policy configuration, and, you know, the way you have named interface ranges, you whack a policy on it, put ports in that policy, and it's all just done, you know. It's very much more modern than iOS. iOS is, I don't know what Cisco are going to do, but they can't keep like incrementing iOS by 0.1 of a version forever, right? You know, they've got to eventually chuck it out, which is what well, I can't remember what their flagship OS is now on those carrier grade things that they sell as. But yeah, so I think there'll be probably more GNOS stuff used in the future, I'd imagine. So, and yeah, very cost effective for like a 48 port full gig switch. If you get, it's in the thousands of dollars, not in the tens of thousands of dollars. So, but we still don't have a cost-effective solution for that number of fibre distribution ports we need in one unit. That the starting price is, 40 or 50K. We need 2 or more for faults, and that's a big chomp out of the technology budget to spend that. So. Yep.
So what do you do with all the kit after the show?
A lot of it goes into stores. Some of it comes out for other events. We'll always do at least 2 events per year for Microsoft, and sometimes, depending on what the circadian rhythm of Microsoft product releases looks like, as to how many times that kit might come out. So if they do a roadshow, which invariably will probably happen with 2012 and Windows 8 because they're going to be such huge products for them, then obviously you've got 8 events that you've got to run around the country. So, yeah. Anyone else?
I think there's some people at the front here itching to get your tag, mate.
Yeah, the tag, that's right. Yep. Sorry? Yeah, I haven't looked at it too closely because we've got so much I haven't had to. But I think the biggest sustained period I saw was around about 350, I think. Like that was actually the 5-minute averages, so your peaks would have been something more than that. I haven't got the counters in my head because I've just been fried with a lot of operational issues over the last couple of days. So, but yeah, I mean it's I guess that we've made the point where we've sort of made these incremental improvements to the event over the year, and it's part of bringing Microsoft on a learning curve about what it's like to do, starting off from a position of using whatever's in the venue, which is what it was like 5 years ago. They've got a tail of this, or they've got this particular Wi-Fi service, to then realising as usage patterns have changed for the event, there's more Twitter, there's more Facebook, all that sort of stuff that people rely on, how critical that sort of connectivity has become. And so whilst maybe 4 years ago you might have got away with the 5-minute outage, today you get the strips torn off you because of social media. And not only that, but people need it. Like the event's practically paperless. Now we've got like 2 printers. We used to, 2004, we'd actually have a pallet of paper turn up, or 2 pallets I think originally, and now it's just 2 crappy little printers sitting on the internet cafe bar. And it's a funny point that Ben brought up. It's just a different world to the enterprise when you're doing these things, because for us a SEV1 is a printer being out of paper. Right? If people can't print their boarding passes, it's actually a really huge issue, and there's no other environment in the world where anyone gives a toss whether a printer's up in 5 minutes or not, but here they do, so yeah.
And an hour is actually 2.5% of the entire event.
Yeah, that's the one figure that you've really got to think about. Whatever your SLA is that you guys are bound to at work, that's like a good chunk. It's like your network being down for 2 months in terms of your own time at work, and as you can appreciate, then everyone says this turns into a big blame storming exercise, and then the media catch a sniff of it, and it's all downhill from there. So we take the uptime of the network extraordinarily seriously because the brand impacts are just too big. Yep. No, I've dodged a lot of bullets actually. I've dodged an epic amount of bullets. Don't have too many scars, so yeah. Yep.
Can you tell us about some of the operational issues you've had over the past few days?
Over the past few days, let me think. Sorry, literally, I've been here for 3 weeks and working 16-hour days, so my short-term memory recall is not as flash as it normally is.
We had an issue this morning with the demonet infrastructure where one of the cluster nodes failed. That was before any speakers got on site. I mean, I think the tech ops is staffed for not just the hours of the event, it's well before and well after. Yeah. So that was caught early, and the session that was running wasn't impacted, but that was just one thing, and it's a down tools, fix it, get it done. So one example is one of the other suppliers, escalated to SEV1 as like critically impacting a particular area in the event, and of course, you get completely derailed from whatever it is that you're working on. Go down there, and one of the Junipers is sitting there with the system light on, and went, no traffic going through it. It does look buggered, and so. Went to download Putty on this laptop I just grabbed on the way out of TechOps, and as I had to shut down Windows to turn the Wi-Fi on it because I go out to the floor with Wi-Fi turned off for the recharge bars. Windows needed to do 2 updates, of course, because someone had downloaded something from Windows Update, and I'm like, And in the process of doing that, it came good again, and I said to him, it just seems to have righted itself. I haven't even logged on yet. And he goes, oh yeah, we just bumped the power before. So well, when that happens, they do this thing called booting, and you have to wait for that to finish.
you know, and that costs you an hour, right? Because it's the whole cognitive, like whatever I was on, I've just had like just been T-boned at a mental intersection, and then you're, you know, coming back and you've got the blood pressure, adrenaline rush of all these people like, you know, we can't do X, and it turns out to be a non-issue. So that absolutely pisses me off, but it happens all the time. So, but yeah, that's right. So it's just a lot of random junk like that ends up chewing up your time. You know, you get to the end of the event, I feel like I've been on the Gold Coast for maybe 2 days, is what I feel like at the moment. Like when I left home, my 7-month-old could barely crawl, and then my wife sends me a photo of him standing up at the couch. I'm like, oh, I'm actually quite a bad parent. I haven't seen him for a month almost. But you get this weird sort of haze about what you're doing, where you feel like you've only been here for 2 days, you've been here for 3 weeks, and then suddenly when you come next year, it's like you've never left. It's quite bizarre. So, yeah, don't ask me what I've done for the last 3 weeks. I don't really know is the answer. So, yep. No, we knew that immediately. So the deliverables belong entirely to, like there's separate siloed vendors that do different things. So, you know, our service interaction with that particular supplier is we give them a internet tail, check it's commissioned, and see ya. You know, we give them switches and let them do that for their imaging and so forth. But yeah, that's the extent of it. So, you know, it's not an ideal situation, but as I said, you know, it's bad for you guys, right? Because you don't see who's doing the work and who's not. It's bad for us because if someone drops the ball on something, then suddenly it's just Microsoft, and ergo everybody under that cops a flogging. You know, I guess they're doing the right thing by trying to compensate. I don't know what the current plans are, but I've seen the stuff going out on Twitter that they're compensating people to some degree. So I hope that's enough for you if you're one of the PCTT attendees. Yeah. Yeah, I mean, they're good about it, you know, and they know to stand up, and they would never hang anyone out to dry to say this was what happened or that's what happened, you know what I mean? It's just like, it's our brand, we did it, and here's how we're going to make it better. Yeah. Oh, I did, you know, it still affects us all, you know what I mean? Like, because at the end of the day, we still see it as like, well, you know, how far do you get involved in that? And then if you go and try and solve that issue for someone that you're not on site contracted to deliver a particular aspect for, then how does that equal in terms of the operational responsibilities we've got for the stuff we're being paid for? So, you know, there's sort of, you want to help, but then you're going to drop the ball over here, and then you have 2 issues if you do. So, yeah. Yep. Sorry?
That's a Mr. Haysom question, but...
Where is Mr. Haysom?
Yeah, that's right. So, I mean, for the server infrastructure, it's a 3-hour backup. We're obviously dependent on a lot of the labourers and staff that are around doing lighting and whatever, so it's a very well-coordinated set of events. So
the issues there are we've got to get all the factory images back on for the machines to go back for resale or wherever it is that they go, and so you get staging guys come in, take the power, halfway through an imaging session, oh no, sorry mate, need to take this, and then you're basically stuffed. And also the problem is that the cost of the hire of a building like this is extraordinary, so once you get to the end of the rental period, it's like, or literally, it's Friday, yeah. So tomorrow, there's another event bumping in. So we literally have to shut down the Wi-Fi as soon as the keynote closes, like it's just gone, and then we've got to cut all the IDFs back over. Like all the APs have to come off. They have to go back to the HP stuff that's built into the venue. Cut all their VoIP system back over, off our system, all that. We've got like an hour to do that in the Savo. But it is pretty fast to pull stuff apart and put it in a box as opposed to putting it together and configuring it. So, yeah. Anything else? All right. Well, if you have any other questions, feel free to come down the front. We'll hang around until the next speakers turn up. Other than that, thank you.